didn't prove anything, but we already explained the concept about the proof. Of course, it had better escape. Find the critical numbers of the function f. Okay. Critical numbers is about differentiability of this function. So we find its derivative first. F prime of x equals power rule 3x squared minus 2 times 3 is 6x. The constant whose derivative is 0. We factor this polynomial to obtain 3x x minus 2. Okay, because this is a polynomial function, it is differentiable everywhere. So to find the critical number of this function, we simply solve this equation. And if this is 0, then one of the three numbers will be 0. So x equals 0 or x equals 2. The critical numbers are 0 and 2 of f are 0 and 2. Okay, for B, rewrite this function. Now we use distributive law 4 times x to the 3/5 minus x to the 8/5, because 1 plus 3/5 is 8/5. Again, we use power rule. So 12/5. This is minus 2/5 minus 8/5 x with an exponent 3/5. Power rule. So this exponent is larger than the first one. Oh no, we have to use the smaller one. Smaller one is this one. So this is x minus 3/2. We choose the smaller one, take the smaller one outside. This exponent is greater than this exponent by 1. So we have x with exponent 1 here. And minus 8/5. Okay. Minus and minus plus. So 12/5. Okay. So maybe we use this table to make things more clear. X, f prime of x. Here, x 0 and 2. At 0, the derivative of f is 0, and 2 is 0. If x is greater than 2, then x minus 2 is positive. If x between 0 and 2, x minus 2 is negative, x minus 0 is positive. So, f prime equals 0 if and only if x equals 0 or 2. Similarly, for this one, x, f prime of x, this means or okay, so a critical number will be 3/2 and 0. At 3/2, this is 0. And at 0, at 0, when x equals 0, by continuity, this number is almost 4 times this one. Because the exponent is less than 1, it is not derivative at 0. Okay. Not differentiable at 0. A wrong reasoning is this. When x equals 0, the denominator will be 0. But this is a wrong reason. We already mentioned this before. In order to see whether this function is differentiable at 0 or not, you have to use definition. F of x minus f of 0 over x minus 0, then find its limits. But coincidence. If anyway, I already explained this before. I don't want to take time to explain again. For the sign, positive or negative of f prime, the derivative of f, because there is a squared here. So if x is not 0, then this term always positive. Positive, a minus sign here. If x is greater than 3/2, then positive, minus. okay? Because you can't ignore this. This is always positive. Always positive. So the sign is completely determined by this factor and this sign. If x is greater than 3/2, then it is minus. It's less than this one, then positive, except at the 0, because this number is always positive. Okay. According to this, we know the critical numbers of the function f. Know that because this is an odd number, this function defined everywhere, containing the origin, 0. So 0 is in its domain. Zero is in the domain of f. Okay? Got it? So please notice, because this is an odd number here. So x is, this function is defined everywhere for every real number. We have mentioned this before many times. If 0 is not in its domain, then 0 cannot be a critical number, because the definition of critical number already the statement, the necessary condition. The premise is that the number in the domain of f. Find the absolute maximum and the minimum values of the function on this interval. Okay, this is a closed and a finite interval because they are equality here. And this is a polynomial. Oh, this is the same as the before. Okay. This is a closed and bounded interval, and this function is continuous on the closed and bounded interval. Therefore, we use the closed interval method. The derivative of the function is 3x squared minus 6x, 3x, x minus 2. We use a table. Minus 1/2, 4, and 0 is inside, interior to this interval. and the 2 is also inferior to this interval. So this is the only critical numbers, the 0 and the 2. Also, the boundary points are -1/2 and 4. Then we find the values of f at numbers from step 1 and 2. Step 1 is the values of at 0 and 2. If x equals 0, this is 1. If f equals 2, 8 minus 12 minus 4 plus 1 minus 3. And at -1/2, oh, so 1/8. And at 4, uh, 16, 17. Okay, this is step 2. Step 1. Find the values of the function f at critical numbers. Step 2, find the values of this function